Settle down, class. We are going to go over diesel engines today.
Professor Banana Face, I thought we already went over automotive engines. Yes, we did. But there are a few key differences between gasoline and diesel internal combustion engines. Let's start by going over the obvious one. Diesel engines run on diesel fuel.
How is diesel fuel different from gasoline fuel?
I'm glad you asked. Both diesel and gasoline are hydrocarbons, but diesel usually consists of a longer chain of hydrogen and carbons. This makes it so the efficiency of diesel is different from that of gasoline. On average, diesel is able to produce 38.5 megajoules of energy per liter, whereas gasoline can only produce about 34. This means, on average, diesel engines are about 20 to 25% more efficient than gasoline engines.
So diesel is more efficient than gasoline?
Yes, but that is not the only difference that comes with using diesel fuel. Diesel fuel is a less flammable and volatile substance when compared to gasoline, and has a much higher ignition temperature. Because of this, diesel engines do not ignite their fuel using spark plugs, but rather through high compression of the fuel and air mixture within the piston cylinder.
Wait, that doesn't make any sense. You're saying the gas just decides to explode out of nowhere. How is something like that controllable?
You are missing a few key points. Think back to high school physics class, when you learned the ideal gas law. PV equals nRT. Pressure times volume is equal to number of moles times the ideal gas constant times temperature. Yes, this law that you thought was pointless has real-world applications. If we look at this equation, we can see that as the volume decreases, we can be certain that both pressure and temperature will increase greatly, since both number of moles and the gas constant will not change. This rapid increase in temperature and pressure is enough to cause combustion through compression.
So the engine does not need spark plugs like a gasoline engine?
Exactly. Now you are understanding it. Keep in mind that these differences mean that different steps and precautions are required in the design process of a diesel engine. For example, the injectors in diesel engines shoot out at around 20,000 psi, compared to an average of 50 psi for a gasoline engine. Changes like mean that diesel engines are required to be built sturdier and more resistant than gasoline engines, which means upfront costs are usually greater from diesel engines compared to gasoline.
Wait, so if they cost more and require more safety standards, why do people opt for diesel engines over gasoline?
Well, if you remember from earlier, diesel engines have better fuel efficiency, which means some cost can be saved in fuel prices. However, usually diesel engines are much larger and require more fuel than gasoline engines, either way. However, the real advantage comes from the power you are able to get out of these engines. Diesel engines are able to produce so much more torque than a gasoline engine. For example, a 2025 Toyota Supra with a 2-liter 4-cylinder engine is able to produce 382 wheel horsepower and 368 pound-feet of torque. These stats combined with a lighter weight means the Supra is able to go pretty dang quick. Whereas 2025 Ford F550 has a 6.7 power-stroke turbo diesel engine, which has around 500 horsepower and almost 1,200 pound-feet of torque. 1,200 pound-feet of torque means big power, and that the Ford is able to pull heavy loads.
So, high-torque producing engines are good for towing.
Yes, having a high torque ratio means the engine is going to be able to pull heavy loads fairly easily. This is why all large shipping trucks use diesel, because its properties align more closely with pulling heavy weight.
If diesel engines are so strong, why are they only used on trucks?
They are not used only on trucks. The scaling of diesel engines is amazing. They are used to power things for construction, like excavators and bulldozers, generators for energy, ships and boats, trains, and even sometimes small aircrafts.
Thank you, Professor. I learned so much. Now I'm ready to build a car.
Now you know the basics of the diesel engine. Like the video if you learned something, and subscribe for more. Thanks for watching.